Okay, Assalamualaikum. So we are going to start with chapter 8. We have a 3 subtopic. We have chapter 8 will be special distribution function. For the first subtopic, binomial distribution. Second subtopic will be having Poisson distribution, and the last subtopic will be having normal distribution function. Okay, for the 8.1, binomial distribution is the most easiest distribution. So I'm going to see it together, which is, if you try to look at here, identify the binomial distribution and use it to solve the related problems. So a trial with only two possible outcomes is called as Bernoulli trial, which is will be having only two outcomes, either fail or success, head or tail, pass or fail, and so on here. And how many experiments that will be performed? The probability is only two outcomes and do not change, okay, from one trial to the next. Let's proceed, which is this is quite important. Okay, the formula for the binomial probability distribution, which is will be having this one. I think you're already familiar with this example, with this formula, which is will be having NC and choose X P per power of X here, and 1 minus P, or we're going to have it as a Q, and minus power of N minus with X, which is X is equal to 0, 1, 2, 3, until N, which is in here, X is the number of success, okay, N is the number of trial, okay, and the P probability of success, and 1 minus P, which is of course the probability of failure. So this is a symbol for the binomial distribution. This is quite important for you. What is N, what is P? N we already said before, which is number of trials, and the P, which is probability of success. So let's proceed. Okay, for example, 8.1 already have a solution. No worry. A coin is tossed 3 times. Okay, just imagine you have a coin and toss 3 times there, and find the probability of getting no heads. Exactly 1 head, exactly 2 heads, exactly 3 heads. So X represents the number of head obtained. So we'll be having what? Our binomial solution will be having the number of trial is 3. So it is tossed 3 times, and which is probability of getting no heads or heads. So it will be having 0.5. Why? Because of what? 1 out of 2 will be no heads, and 1 out of 2 will be the heads. Okay, so we can answer it, which is probability of getting no hits, X is equal to 0, so this is your answer, and exactly 1 hit, X is equal to 1, so this is your answer, and X is equal to 2, exactly 2 hits, X is equal to 3, exactly 3 hits. What I want to advise for 8.1 here, please try using your calculator. Please do practice using your calculator. Let's proceed. Example 8.2, which is in the basket, 20% of all apples are rotten. If a random sample of 10 apples is taken, okay, exactly 3 apples are rotten. All apples are good, not more than 3 apples are rotten. So in the first place, you need to represent first. X is represented as what? X is represents the number of damaged apples or the rotten apples. So the binomial distribution that we'll be having here is the number of sample here is 10 apples, and 0.2 comes from the 20% here, which is comes from 20% for the apples are rotten. So since we want exactly 3 apples are rotten, so X is equal to 3, so this is what you are going to have, and all apples are good, which is we doesn't have a rotten apples, so X is equal to 0, and not more than 3 apples are rotten. So maybe you can put some notes. Your probability, not your probability, which is your inequality, is quite important. They are going to ask you using the words, and you are going to represent in the form of inequality. In this case, not more than 3 apples are rotten. So X less than or equal to 3. X less than or equal to 3 will be having X is equal to 0, X is equal to 1, X is equal to 2 until X is equal to 3. You are going to use your calculator to calculate everything here, so you will be getting this probability. So please make sure you practice using your own calculator here. So let's proceed. Example 8.3 doesn't have a solution, but the question will asking to draw the graph. So try to draw the graph there, and let's proceed. And if you try to look at the conclusion, they are reflecting to each other actually. So because of what? The number of trials are having the same number of trials, but the probability, this is 0.3 and this is 0.7, they are complementary to each other, is it right? So actually they are reflected to each other, the graph itself. So maybe you can try to sketch the graph, okay, when the x is equal to 0, y is equal to 3, and y is equal to something on there. Okay, let's proceed with example 8.4. Example 8.4 already have a solution here. Okay, so finding the number of trials in binomial experiments. Okay, now 8.4 will be a little bit tricky, which is right. The probability that football players scores a goal when a penalty is given is 0.4. Find the number of penalties which must be given so that the probability of scoring at least one goal is more than 0.9940. I already have the probability here. So we are going to let first, we already know the n is equal to number of trials, in this case penalty trials, and the x is the number of goals scored out of n penalty kick. So p is 0.4, which is the p is a 0.4, the penalty given, and the rest of it, which is q, is equal to 0.6. Okay, so we already have a q as a 0.6 here, which is the rest of the penalty, which is not given penalty lah. So you're going to see for the next one, which is in the binomial distribution, n is the number of trials, just put it there, and we already let number of goal scorers of an n penalty kick, which is as x, we're going to have a 0.4 here, and we are going to have what, which is probability of scoring at least one goal is more than 0.9940. Okay, which is the probability of scoring at least one goal is more than 0.9940, which is you can write it in the form of probability of x more than or equal to 1 here, which is more than 0.994. So this is what you're going to have. So maybe you can put or highlight this one. So then the next one will be having 1 minus p, where x is equal to 0 here, because we doesn't want, we just want x less greater than or equal to 1 over here, right? So it will be more than 0.94 here. So x is equal to 0 will be less than 0.006. So we are going to use the formula of the binomial distribution, less than 0.006 here. We already know we'll be having 0.6 power of n less than 0.006. So we're going to solve this part using the indices law. So you'll be having indices rule. So you'll be having using the logarithms, okay, using the ln that you already learned before in semester 1. So you'll be having n here, and more than ln 0.006 over ln 0.6 will be equal to 10.0152. So the conclusion, the number of penalties is at least 11, because we know we cannot have 10.0152 for the number of penalties, right? So we want to have 11 because of what? N is more than 10.0152. So the least one that you can get is 11. So I hope you're clear, which is if you try to look at example 8.5, 8.5 will be quite similar as the example 8.4. Just try it first. 8.5a, 8.5b, if you try to look at here, it is a simple binomial distribution. As for example 8.5c, you may refer from the example 8.4, which is the answer will be 13. So let's proceed, which is next. We will have mean and variance of binomial distribution. You may highlight this one. The mean will be going to have n p, and the variance will be going to have n multiplied with p multiplied with q. So please highlight this too. So it is important because you are going to use in the subtopic 3. So example 8.6, if you try to look at here, already have answers and solution here. Just try it first. Okay, so okay, for question A and B, the number of trial will be 10, the probability will be 0.55, but just for A, we'll be having probability of x is equal to 7, probability of x more than or equal to 7 for question B. So you may try it first. Okay, this is for the expected, which is expected number. Let's proceed. Example 8.7, you need to try it first, but I just want to give some hints. For example 8.7a, the number of trial is 10, the number of probability will be 0.05, and the reject will be x more than 2, not reject x less than equal to 2. So we want to have number of boxes that will be rejected. So we'll be having x more than or equal, x more than 2. As for B, the number of tries is 10. I will be having the new probability will be 0.04. So we need to find x more than equal to 2. Try it first.